So in today's session, I'm going to talk about one more point. Mainly, now we discuss last few sessions about how to handle data, especially in machine learning algorithms. But the only difference, if you compare this with natural language processing, in natural language processing, we mainly focus on the texts, right? So before we move on to natural language processing and the related task, so we are going to look at, first of all, how to handle text data. So under this, we are going to discuss how we can handle text in various ways and how we can actually match text in the way that machine learning algorithms can use. So those are the few ideas that I would like to discuss. So this is the text classification. But then again, under this, we need to discuss various other things like how data is represented, the different data representation techniques, especially language modeling, and related tasks in natural language processing. So simply, when you talk about the problems in, especially in natural language processing techniques, especially we have to know more details about the language itself. Rather than going through look at this aspect, here we are just going to treat this as another data type, right? So let me briefly discuss about how we can actually handle text. So this we can normally say that this is like neutral model of document classification. Simply what we do in this particular case, we can assign one or more categories to text documents. So for example, think about some movie classification problem where like we have a movie description in plot, and we can assign a label based on the plot. So you can see that, based on the plot, we can make it a label. So that's very similar to the ideas that we have discussed so far with the machine learning idea, where you have a data and then you put up label. The same way. But then again, this could be done in two techniques. We can automate it. That's what we are going to discuss, how we can use machine learning techniques to automate this text classification task. But the second one is manual, especially during creating the labels. We need some expertise to start with. So usually this is the two techniques that we can talk about. But if you evaluate the two techniques, you know that automated and manual, there are distinctions. You can see the differences in the cost, especially if you use manual labor, it will be cost a lot. And the speed will be slow, the accuracy, human tend to make more mistakes, whereas like automated techniques, we have high efficiency, high speed, and low cost. Right. Now, if you look at what applications we will have, so there are various applications we can say. For example, think about your spam filter. Let's say in any email application, you have a spam filter where the already built-in text classifier. When you receive an email, it will automatically classify whether it's a spam or not. Similar to that in news, for example, there are some websites where they have automatically classified the news based on the different categories. Web pages into subject categories in some places. We can have, list of web pages, but when we'll put them into various categories. Then research papers, especially those who work in the research, this is very helpful. When you're given a set of papers, to be able to classify them into various subject categories. Right. The approach in manual, simply we have to go through the document and classify it, and that will be the task, especially in the beginning. But in automatic, we will use the machine learning approach. So in machine learning approach, what we do, the same thing that we have discussed so far, we can create classifiers from the text documents. So simply the difference would be, instead of bunch of kind of a matrix usually we see. So in this the text data, we don't have matrix form, which we are going to discuss. Then you have to manually assign the labels to the training set. Of course, you have to have like manual labeling for this. And then we need to classify to predict the category of the new document. Right, now let's focus on the documents. Now, like in training and test data set, now this time what we have is set of documents. So you have set of documents for training and the set of documents for the testing. And more important point is we need to represent the document. So how we should represent the document? So the document representation, and we need to transform the free text, that means a bunch of text, into a format where our traditional machine learning algorithms can learn from data, where it expects a matrix form. Right. Now here is, we have a one example. You can have news. Let's say this is the document, but you see there are a lot of information in here, right? So it's not a bunch of text. You see that there are some headlines, there are timing information here, there are key highlights, and then we have some links and we have a key image. All these actually gives you a different piece of information with the different importance, which you should take care of in text classification, right? So what is it in the document? Simply, you can see the text content. That's what you will see at first. But there are many others. For example, in a document, you have a structure as well. Like I said earlier, you have a title, you have a timing information, you have highlights, you have main image, and the text, and so on, right? So you have facts, you have layouts, like how they have placed it. The structure is one thing, but the other one is layout. Like, for example, if I relate to the HTML, we can talk about the structure like head, H1, H6, like different, structural elements. But the layout, then maybe the CSS. Right. So let me start with a very simple bag of words representation. When I say bag of words, in simply, we are going to talk about the problem with the text. We discussed that. Now, machine learning algorithms, usually they prefer to have a fixed length of strings, input and the output. So if you give a text directly, any of our algorithms cannot work. So, and this text should be converted to set of numbers, right? So that is what we need to do in this first phase, right? So what is this bag of word representation? Or in short, we say BOW. So this is a way of, extracting your features from the text. So that it's very simple and very flexible. There are many, other advanced techniques which we will discuss later on. For the time being, it's a representation of, set of words we call vocabulary, right? So simply it will compare words, and simply it will not it will not consider any ordering in the text. For example, let's say we have three documents. D1, the dog sat on the floor. And the D2, the man sat on the floor. D3, the man walked his dog. So these are like represented in three documents, three simple sentences. I hope it's very clear. And what we do, right? So each of these words, first of all, you look at this vocabulary. That means we have article the dog, the sat, and on, the floor. So likewise, you go through each and every word in this document, and that will be the vocabulary. So using this vocabulary, so one side we have this vocabulary, the set of keywords. And then the other side, we have the set of documents. And we can indicate whether that particular word is there in the document or not. So for example, if you look at the second representation, we say dog, floor, his, man, on, sat, the, walked. So which means in the document D1, we can represent in two ways. One, you can say whether the word is appeared there or not. Right? Second one is we can put the frequency. So these are like two representation. But remember, there are various issues that we have to discuss, which I will discuss, separately. Especially, for example, right now we put everything in simple letters. But ideally in document, there are various ways of document representation. For example, there could be multiple cases, your capitalization. There could be punctuations, right? Sometimes we have make mistakes, misspelled words, right? And then sometimes we have different word forms. So all these, we have to manage them, right? So that's the way we have to handle them. Right. Then once you do that, usually we get this, and then we have the documents. And the simple one, we can represent, we can have the frequency. For example, how many times the word appears. So if you look at the first record, the dog sat on the floor. We have dog, floor, on, sat, the. So all will be one, and the is applied twice in the document. So therefore, you can see the frequencies too, right? So we can actually represent in this form. Right. Now, the next point is, when you want to create what words needs to come for this vocabulary, you have to look for the frequencies as well. A small question. Now, this is some frequencies you will get. Let me resume. Now, term frequencies will tell us how frequent these items are appeared in the documents. So if you take like words like the, it appears everywhere, which means there's no, if everywhere means there's no information, because you can't use it to separate because it's in all the documents. If it is, it's not frequent, like it appears only once in the document, that is also not important. So we should try to find a balance in between, not too frequent, not too less frequent as well. So we need to find a set of words in the middle of this region, right? Which will be our the vocabulary, right? So remember that. So you can take the term frequencies, but then again, you have to be very careful about using them. Right. The second one is, not all the words are important. So things like articles, they are not important for, and it doesn't contain any information. So we will say it's what we call the stop words. And usually we can remove those stop words. Right. So we can say that words occur in a document. But if it's in many documents, then they say that it's not that important. So these words we call the stop words. Right. Examples, words like about, according. The set are going to say the stop words. But remember that this might be sometimes subjective, depend on the topic that you are going to choose. So you have to be wise to select which stop word list you are going to use. Usually, you can, there are like some standard stop word list that you can actually use. Right. So having said that, you have to treat these words in a special manner. Most of the time, you have to remove them. So that's how it should be treated, right? So given a text document, usually this is how you should work on it. Then another operation that is very interesting is what we call the statements. Now in the stemming, for example, we see sometimes in documents there are different form of the words, especially item with its plural form. For example, house with houses. Then derivational, derive one word from another, like health, healthy. And then we can use stemmers to get the basic form of this. Now, for example, if you take word forms, like we can have go, went, gone, and so on, which means if you look at the root form, it should be go. So therefore, we need a way to get the different form of the word and to make it to the root form. So in English, usually we use the commonly used stemmer is called quarter stemmer, which will remove the suffixes. Right. Now, once you do that, you will have the what we call the index terms. So we said the vocabulary or the word will be features. But sometimes the just single word is not enough. For example, if you say in front of, it usually goes together, right? So sometimes using words are not enough. You have to look for phrases. And then sometimes take multiple words together. If you take one word at a time, usually we call unigrams. When you take two words at a time, we will call bigrams. If you take n words, then we call n-grams. So that's how you used to go. So n-grams, as the word says, it's a sequence of n words. So if you look at the whole process in a one setting, so you start with the document with all these punctuations, all these character forms and so on. Then you remove any punctuations and maybe convert into one form. So in this particular case, you can see that this is converted into capital letters, all capital. Then you remove any stop words like man, walk, dogs, the articles and his pronouns were removed. And then you have remove the stop words and then you will get man, walk, dog. You use the stemmer to get into the root form, walk into walk, and then you end up with your features. So you can see now, we start with the man walk his dog. The index terms, we are going to, filter the text until you get 3 words. Right. Now, one issue is if you are going to do like this, think about a document where you have 100,000 words. You will get thousands of words as features, right? So what it means, right? When you have a large number of features, usually your classifiers will perform really badly. So that means you have to carefully select your features. So feature selection or term selection is a very important idea, right? You have to select features. So the idea is, given a set of features, you normally have thousands of features if you're using a text data set, but you have to reduce it to a smaller set where you have a improved accuracy if it is a classification problem. Right. Usually what we do, we use 2 approaches in machine learning. We can use a wrapper approach or a filter approach. In wrapper, what it means, like you will select a small set using a particular machine learning algorithm. So what you can do is you can iteratively work on the set of features you can add and remove, and then you evaluate the performance of the algorithm. So the set of features that you are going to select is measured by the machine learning algorithm. That if you're using a machine learning algorithm to select features. The second approach, we call it filter approach. In filter approach, usually we will select features based on some measurement. I hope you remember we discussed something about the purity in creating decision trees. And the measurement we use is called information gain. So we can use information gain to rank our features based on the highest information gain. And then we can discard the low number of, information gain, the features with information gain. Right. So if you compare this with the previous approach, the problem with the previous approach is very expensive. So each and every feature combination, you have to perform, right? But in filter approach, it's not like that. Uh, you can simply arrange the features based on the importance, and then you can select top features based on that measurement. So for example, if you use information gain, so you first get the information gain for all the attributes, sort them in a descending order, and select the few based on the highest information gain. Right. With that said, so this is what we are trying to discuss in the implementation.